Multiple stage countercurrent solid liquid extraction. In this process, you will be introduced into the calculation for multiple stage countercurrent solid liquid extraction or leaching process. As this is for multiple stage, so the ultimate objective is to determine how many theoretical stages required to carry out certain process. The process principles involve first, still the same three components consist of solute A, inert solid B, and solvent C. The composition of the solvent stream V and slurry stream L will be denoted by the X and Y respectively. The assumption is solid B is insoluble and the liquid phase of A and C will be continuously underflow from each stage. The flow rate of a solid also assume constant. The slurry phase L composed of inert solid B and solid A, and sometimes it contains solvent C. The ideal stages are numbered in the direction of the solids or underflow streams. That's mean the lower number of ideal stages shows that there are a lot of composition or solid A as compared to the stage with higher number. Figure 1 here is showing the process flow diagram for countercurrent leaching process. So at the inlet here is again the same as what you have learned for a single stage. So it has the slurry solution or solution. It is a mass of liquid in underflow solution with the composition Y naught, and the amount of inert per solution is N naught, and B as the mass of a dry solute, free solute. And coming in for the countercurrent on top is the amount of solvent with its composition labeled as stage N plus 1. And the outcome of the slurry solution is the leach solid, and here is the overflow or the extract of the solvent stream. V is mass of solvent in overflow solution, and YA and XA is the composition of A at the underflow and overflow solution respectively. So figure 2 is just an example if this process consists of 3 stages countercurrent leaching process. So this is the feed for slurry stream, and the outcome is the leach solids or underflow, and coming on top countercurrently is the solvent or the liquid stream, and the outcome is the extract or overflow. The mass balance for multiple stage leaching, we look at the overall mass balance over the first n stages. So the overall is input is equal to the output. So this is the input for liquid stream or solvent, and this is the input for slurry stream. Vn plus 1 plus L naught equals to the output of the overflow, and this is the output of the underflow or leach solids. And here we come for the component balance. So as you know that X and Y is the composition in the liquid and slurry stream respectively. So multiply these two will give you a component balance for the input and the output. Overall balance over total solution. So total solution balance, input equals to output, and here is the intermediate phase. And for the component balance, the input equals to output and the intermediate. And the same solid balance applied, B is equals to N naught L naught equals to NN LN, and it is equals to NM M. So what is the purpose of having this mass balance? So this mass balance to give you the operating lines and as well as the component or the amount of the final exit. So we always interested to know what is the amount at the exit from the exit stream. Okay, an equilibrium diagram for multiple stage. You will have the same. The vertical axis is N, and for the horizontal is YAXA. And you can start to draw N versus YA. It could be a plot of N versus YA where it shows that this N is not constant. You might have a constant value of N versus YA where it's coming as a straight line. Next, locate for the what position is this? L naught, right? So L naught, and this is the Vn plus 1. This is for a case where it has certain amount of the solute composition. And another one here is the Ln, and this is V1, right? Okay. And next is the intersect here representing M. Okay. And you need one more line connecting L node to V1. Just make a line going straight. And here from Ln connecting to V1, which intersect down here will give you the triangle as an operating point. The point triangle is located graphically as the intersection of lines L node V1 and Ln Vn plus 1. And from here, you make a straight line 90 degrees and going down again. So this will give you another line straight. So going straight here will give you L1. And here another 90 degrees. This will give you L2. And from L2, just make a line connecting the operating point. So you might have another one line here. So this is 90 degrees and this is L3. So L1, L2, L3, and this is not possible to go anywhere here. So Ln is the last stage if you look at this diagram. So if you can count, there's going to be four theoretical stages. Okay, just a summary for this multiple stages counter current leaching. First step is to locate the L node and then draw a line L node operating point to locate V1 from L node to the operating point to locate V1, and then a tie line through V1. This will locate L1, and then the line L1 operating point is drawn given the V2, and this V2 finally will give you L2. So all this will need to be repeated until the desired Ln is reached. Thank you.